it's Mrs. Pound here, and I am back with more from Chapter 1.2, Nature of Matter. We've been really working in this chapter for quite a while. We've been talking about different properties of matter. We have been talking about each of the states of matter, and today we are going to talk about phase changes, changing from one state to another, and this is from section 1.2.6. So our objectives today are to infer the behavior of molecules during a phase change, explain what is necessary for a phase change to occur, identify characteristic properties associated with phase changes, and define the law of conservation of mass. So a physical change is a change in a substance's physical properties that does not change the type of matter in the substance. So we can see in the background I have paper. But if I crumple that paper up, if I rip that paper, I still have paper. Okay, so a physical change is taking a substance and doing a number of things to it and still having that substance. I still have paper. A phase change is the changing of a substance from one phase to another, or from one state of matter to another. So a solid to a liquid to a gas to solid. Okay, so we're going to cover each of those changes. So melting is when a substance changes from a solid to a liquid. That's when you have those particles that are just vibrating. You add enough energy that now they start to slide past one another. They're breaking up some of those cohesive forces between them. This generally happens with crystalline solids at what is called the melting point, the temperature at which a substance changes from a solid to a liquid. And for water, that is 0 degrees Celsius. And until all of the ice melts, and you can see my ice down there at the bottom in the water, until all of the ice melts, that water temperature is going to be 0 degrees Celsius. It will not change. And if you don't believe me, we're going to prove it in the lab. The opposite of melting is freezing. It's when a substance changes from a liquid to a solid, like what happened at this waterfall. And the freezing point is the temperature at which a substance changes from a liquid to a solid. And you can see on this water here, the water is just starting to freeze. And for water, again, this happens at 0 degrees Celsius. Water both melts and freezes at 0 degrees Celsius. Another phase change that happens is called vaporization. This is the changing of a substance from a liquid to a gas, and you can see that vapor coming up off of that cup of tea. Actually, you cannot see water vapor. What you're seeing when we think we see vapor is actually condensation, but it's about the only way that we can tell that that vapor is going into the air because we can't really see water vapor. There are two types of vaporization. The first is evaporation. This is the slow vaporization at the surface of a liquid. So this is if you set a glass of water out over, say, a week, okay, you will notice that the water level goes down. That is due to evaporation. And you can see here, this is at a salt mine. They are evaporating water off of a mixture of salt and water to produce salt. There's also boiling. This is fast vaporization throughout a liquid, and you can see this milk on a burner boiling over. For boiling, there is a boiling point. This is the highest temperature at which a substance can exist as a liquid, and for water, that is 100 degrees Celsius. Different liquids have different boiling points, and water will stay at 100 degrees Celsius the whole time it is boiling until it completely turns into water vapor. And if you don't believe me, we're going to do it in lab. The opposite of vaporization is condensation. This is the changing of a substance from a gas to a liquid. And the examples are dew, which you can see on this spider web in the background, and something like a sweaty toilet or a glass of ice water when you have the water that forms on the outside. The water's not seeping through the glass. It's water vapor in the air that has cooled on the surface of the glass. The same thing with sweaty toilets in the summer. Now, one that you're probably not as familiar with is deposition. This is the changing of a substance from a gas directly to a solid. And examples are iodine, which I'm going to show you in class, and frost. Frost in the winter, or in the fall usually, not so much probably in the winter, but in the fall and in the spring, this is water vapor changing directly to a solid on our plants and different things. The opposite of deposition is sublimation. This is the changing of a substance from a solid directly to a gas. You're probably most familiar with, even though you've probably never actually seen it in real life, the example of dry ice, which is in these bowls in the background. Dry ice is solid carbon dioxide, and when it is exposed to the air, it doesn't turn into a liquid, it goes directly to a gas, and it produces that foggy effect. Iodine also does this, which I'm going to show you in class, and ice in a freezer. Maybe you've noticed that your ice cubes shrink. This is due to sublimation. They change directly from a solid to water vapor in your freezer. And then they form that frost that's all over the freezer, which is the deposition. So we need to know about the law of conservation of mass. This says that the total mass of the substances before the change always equals the total mass of the substance or substances after the change. So if we have, now we're talking mass, not volume, because remember gases take up whatever volume they're in, right? Okay, and volume can change when we change between the phases. We're talking mass here. So if I start out with a gram of ice and it melts, I'm going to get a gram of liquid water. And if I then boil that and vaporize it, I will have a gram of water vapor. So it has to always be the same mass. Conservation of mass. So what happens to a substance when the molecules lose so much energy that they can only vibrate and become completely subject to cohesion? What happens is it freezes from a liquid to a solid. Cohesion in place, okay? Now, I did not cover this with, I forgot to, I did with the vibrating and then it melts and they slide past each other. But then when you have a liquid, they're sliding past each other, they get enough energy that they no longer have any cohesion at all and they're just flying all over as gas particles. Okay, so it has to do with how much energy there is for the motion. And that's different for different substances because not everything has the same melting points and the same boiling points. So it's different amounts of energy and different temperatures for different substances. And that's one of the characteristic properties of substances, that they have certain melting points and freezing points and boiling points. How about if the melting point of a substance is 60 degrees Celsius, would it be a liquid at room temperature? Go ahead and pause your video and think about that. No, it would be a solid because it will not melt until it reaches a temperature of 60 degrees Celsius. Now, I realize my things in the back would melt at a much higher temperature, but I was just looking for something that was a solid here to remind you of that. And the last question here. Do new substances form during a physical change? Big fat no. We still have the same substances when we have a physical change. We're going to talk about chemical changes next video, and that's when we get new substances. So our objectives today were to infer the behavior of molecules during a phase change, explain what is necessary for a phase change to occur, which is basically added energy, and identify characteristic properties associated with phase changes and define the law of conservation of mass. So now you need your 5 questions in your notes, and we'll be back with chemical change next time.